Okay. I've tweeted. Let it begin. Welcome to the stream. Welcome to trains.net for, I guess this is the 4th installment. So, yeah, that's good. Come on. Let's, as usual, run the game. Let's just remind ourselves what we're up to here. And I guess I should have done this first, so Visual Studio, build first. How are we all? Okay, cool. So we have tracks, and what we left with is drawing horizontal tracks. I can't click and drag, which I really want to be able to do, so that's actually that should be on the to-do list. Let's just add mouse drag to the to-do list there. And let's do that first, because that's easy. So, mouse dragging. Pretty much just need to add the mouse move property. But, you know what? We don't even need another method. We can use the same one because, so mouse move will fire anytime the mouse is over our game, which obviously we don't want to draw, but this already checks for buttons being clicked. So, that's probably actually it. Gosh. I don't know why I waited to do this. Yeah, there we go. Cool. We have drawing. There's an obvious flaw with our trains here. None of them connect. So let's do some vertical trains. But might do some refactoring first. Because there's one thing, before we go too far, it's nice to have neat code. This track renderer. No, actually this isn't too bad. I guess this is realistically this is a track renderer that handles straight tracks. And it's injected in here. So having multiple renderers that, you know, one for rendering a straight track, one for rendering a curved track, it's a little bit problematic. To do with here, to do with DI. But, so maybe actually we'll leave this. Let's just sort this out a little bit. That first copy or paste or cut. Yes, I don't know what it does. It's weird. So let's just, what are these supposed to have? Underscores? Nope. Are they supposed to be uppercase? Can never remember the keys of this. Advanced megabase. Cool. Oh yeah, well, that's just going to give me a lot of compilers. Alright, we've got the old-fashioned way. Here I thought I was being smart. Okay. Hopefully you can all still hear me because I can't hear myself anymore. My headset has a way of doing this. Looks like it's still okay. Never mind. I mean, I never really could hear myself. It was just hearing fuzz, but it was reassuring to know the fuzz was there. Let's extract this to a method. No? Come on. Why can't I? Oh, it's still right on there. And let's go render straight track. Why does it do that? Why are all these things out parameters? I've run into this before. It's because they're disposable. I must remember to log a bug about this. Well, maybe it's not a bug. So what's going on is, I'll just undo this. So this using var, this using statement syntax is new in C#8 if you haven't seen it. And it works the same as if I did the old school way. This is more annoying than I thought to demonstrate. It works the same as if I'd done that. Which is to say, this is my thing in my using, And here's what we're gonna, here's the scope we're using it in, and at the end of this point it'll get disposed. Using var syntax is a shorthand. Hello, am I back? My headset has a thing where it dies sort of once a week. Yes, I'm back. Alright, excellent. Well, you didn't miss much. I was just complaining about the extract method refactoring not working with these new using statements. But anyway, so now we have, so rendering straight tracks. So this is just, I'm just neatening up this file a bit. Because the next thing we need to do is render vertical tracks. So this is if we're drawing horizontally. And otherwise, we want to render vertically. And for completion, I'll just do this, because we will eventually have more directions. Maybe today, maybe not. Don't know. Oh, I can do this from my to-do list. So no more mouse track. So I want to do horizontal tracks, and then I want to do vertical tracks. So the cool thing about this is that we can totally just cheat. And I can call render straight track, because both of these are straight. I know that horizontal is my default case, so I only want to do something special in the vertical case. In the vertical case, I can simply rotate by 90 degrees. So what that'll do is the canvas that was here will be rotated to 90 degrees. I will draw horizontally, which is now vertically, and then because in our track layout renderer we are doing a save before I call render and a restore to each track, all that rotation will be immediately set back. So this should be straightforward to test, but I don't actually have anything that's ever going to set the track orientation to vertical yet. So let's do that. So I guess when we add a track, we need to set best track direction. And so we need a reference to our track. And we're going to need to know what the column and the row is of that track before we can do that. One thing I'm not sure of, and will probably change in future eventually. At the moment, track has just got a direction. So it's definitely mutable. And if it's mutable anyway, well, so if track is not mutable, if track is immutable, then, we get some benefits. If we're going to get those benefits, then we want to keep track immutable. Right? We want to either aim towards immutability, get those benefits, or we want to accept the fact that tracks are mutable, design accordingly, and I think we get a slightly easier life. So for example, I'm not storing column and row on track. I'm just passing them everywhere. And that kind of feels weird. So for example, here I've got to set the best track direction, right? So what I need to do here is then say, well, if there is a track, so it contains, if there's a track to the left of this track on the same row, then we want it to be horizontal, for example. Obviously, this is a simplified algorithm, but that's the sort of thing we need to do. If we make track have a bunch more state, potentially the API kind of gets nicer to use. You know, we could go with things like determine direction, and track knows where it is, and so it can find out about its neighbors. Now, to find out about its neighbors means it needs a reference to the game board. So that's a little circular reference there, but we have DI. So there isn't actually any downside to having that, circular dependency, really, as long as we clean everything up nicely. For now, we'll leave it, but I think, eventually I wouldn't be surprised if I end up moving more stuff into track. In particular, so since horizontal direction is actually the default, we don't need to do this, so we can do this track. So if there's a track above us, then let's switch to vertical. So super simple, but we can at least demonstrate, hopefully, that we'll have vertical tracks now. So we draw some horizontally, that's cool. Now this one should be vertical, I guess. Oh, interesting. It's vertical, but it's also off by 1. That's funny. Oh, yeah. Okay, so aside from our clicks being off by 1, we have vertical tracks. That's pretty straightforward, but you can kind of already see the reason why I say this algorithm is very simple, because so if I put a track here, which is going to put it here, fine, that's vertical because there's a track above it, but the track above it is not vertical. So there's no reason for these two to connect. This should actually be horizontal. If I put a track here, fine, that's a bit better because they actually connect. If I click one track here, now if I put a track below that one, this is all sorts of messed up. Okay, so I don't know how to, if I click here, it's going to draw to the left. Yeah. So anyway, I've realized the problem. I'm rotating. It's obviously rotating around the corner. I should be rotating around the center. So that's good. So this track was vertical because it's supposed to be here. This track, though, also should change to vertical, right? So one track setting its direction should change another track's direction. In this case, it needs to not change this to vertical because that would break an existing track. So the track also needs to know whether it's part of a set. So the algorithm definitely needs to get a bit more tricky. Let's just fix up this while we're here. So yeah, so rotate about, and we're going to rotate about, is it game.cellsize divided by 2? Yeah. That should be it, because that should be relevant to our current transform. So we'll just check that. Draw one there, that's excellent. Vertical, yay. Look at that. We have tracks. That's not bad. I'm happy with that as a first point. Oh yeah, that's kind of funny. Yeah, so this algorithm needs to get smarter, and that's kind of why I think I want to put it on the track itself, because it's going to get very complicated, potentially very quickly. So just for a separation of concerns type thing, I mean, I guess we could have a service like a track positioner, track layouter, but yeah, I'm actually, we've already got vertical tracks done. Just update the to-do list there. And order to determine direction. Yeah, we kind of have that. Tests. Tests. Corner tracks. Yeah, we should definitely do all that too. Alright, what should we do next though? Let's see. Let's do some more cleanup. Let's do some more refactoring, because there's something else that annoys me here about this code, and that is math. Math annoys me in general. This code is okay. This track is never used. Makes sense. You already know it's horizontal. This math annoys me a little bit. So what this is doing, and if I if I find all references for cell size, I can find heaps of references. Yep. Yeah, and there's always, so there's lots of multiplication by cell size. There's lots of divide by cell size. Divide by, multiply, which is fine. It's not difficult. But if we ever change this, there's lots of spots to change, and they're only going to grow. So what I want to do is I want to create a helper class that is responsible for translating between pixels and columns and rows. And so this implements, actually let's do that, we can extract it. So I want a int, we'll call it pixels to chords, x, y, and chords to pixels. And this will just allow us to encapsulate our logic here. So and it's very, I mean, it's pretty simple stuff. So pixels to chords is divided by game.cell size. I hope. I'm seriously bad at maths, you guys have no idea. And then this is multiplier. Yeah, that's right. Cell size and row dot cell size. Oh, not that at all. Not cell size. So does not instance that. Oh yes, well I want to extract the interface, so it will. Oh, look at that. The name is right, the file name is right, everything's right. Oh, so good. Love it when a plan comes together. So now what I can do is everywhere that references cell size can become a property of, or can use the pixel mapper. So fortunately, because we have DI, we can just do, so we want columns rows equals pixel mapper. So this one is pixels to chords, the height, and I'm just going to still keep the max one, and then width and height equals chords to pixels. Yeah. So yeah. So we just create a simple service, does all that work for us, and all of this stuff gets a little bit nicer. I'm just going to copy that. So column, row, x, y. And then we don't have so much math. And what we should find is, the other thing I might end up doing, or actually probably tempted to do, is move cell size maybe onto the pixel mapper. But we'll see. Let's go. Actually, what happens if I do chords? Yeah, pixel mapper. Is that the new tuples way of receiving args? Yeah, it is. There's a couple of things happening here. So if I go var chords equals pixel mapper dot chords pixels, yeah. I want pixels equals pixel mapper. So this is a normal boring method call, and what this returns is a value tuple. And so it's represented with brackets, but realistically it's a value tuple of int. And whoa, don't know, press that. So it's a system.value tuple. And what the compiler lets you do, though, is you can express this in int pixels2 equals pixels. So you can express it in this sort of shorthand format with the brackets. So this is, aside from being an unnecessary assignment, it's still a value tuple. And then what you can do, regardless of how you define it, it's just like a normal tuple. So it has an item 1, it has an item 2. There's a two-tuple method if you need to convert it to a full-on tuple. A value tuple meaning it's a struct, so it'll live on the stack, not on the heap, so it should be more memory efficient if you don't need it outside the bounds of the method. Obviously, if you do, it'll get boxed or anything else, but that's what the two tuples are there for as well. So I can access item 1 and item 2, or same thing on pixels 2, I've got item 1, item 2. So the cool thing about this is, let's just do this to keep it clear. So item 1 and item 2 are kind of annoying names. So what I can also do, though, is I can put in here labels, and this is column, and this is row. And so now I can go, so pixels is still item 1 and item 2. Pixels 2 is still item 1 and item 2, but if I go pixels 3, I use a var, this should now, show me X and Y. So the compiler will then will lower that to item 1 or item 2, so we get the nice names. The other thing we can do is we can do something called deconstruction. So I can say int X and int Y equals pixels 3. Now this is not a value tuple. It looks the same, but it's not. What this is doing is essentially multiple assignments. This is assigning two variables, one called X, one called Y. And what it's doing is it's calling a method on pixels 3 called deconstruct. And deconstruct, well, let me show you. Let's create a new class. Didn't know you didn't name the tuple members in return types. What are your thoughts each on this way? I didn't name the tuple members in my return types. Yeah, so I just did that in the interface, which apparently I've closed. So yeah, naming them is definitely the way to go, I think. And also, I think capital letters, so they look like arguments, but to me, it makes more sense to think about them as to where you use them, so the call site. And at the call site, they look a lot more like properties. So pixels3.x. So yeah, I'm definitely in favor of naming because item 1 and item 2 is horrible. Most of the time I find that I just deconstruct like this straight away. So what I was doing with this here, so let me go, if I go x equals new my tuple, and this, oh yeah, actually, you know what, I'm just going to rename this because it's got nothing to do with tuples. So deconstruction is, this is normal assignment. But if I say go, let's go int height and string name. What this is going to do is it tries to deconstruct my class, the instance of my class, into two variables. One called height, which is an int, one called string, which is name. And the names here actually don't matter, but essentially one int and one string. If we hover over the error, we can see it says no suitable, I'm pointing at the screen, no suitable deconstruct instance or extension was found. So the way deconstruct works, if I can remember correctly, is it's a void called deconstruct, and it has an out parameter, has out parameters for each part that we're deconstructing into. And obviously these things would be real values. And yeah, so that's so that error has now gone away. Now it's complaining because I haven't used name, and this is I've picked a bad I don't know, I picked a bad variable name which I already had defined. So aside from this being unused, but so this is how deconstruction works. So value tuple comes with a deconstruction that deconstructs to its component parts, and that's the way that I usually use it. Because yes, if you've got nice names, I mean, changing this to if I do this pixels, and I mean this pixels.x, this is not bad, but for a small thing, I find this is sort of quicker and easier. But that's fine, we can leave that. But the coolest thing about deconstruction is that you can provide this deconstruct method via via extension method. So you can actually provide extension methods, and you can allow any type in anywhere in the world to be deconstructed according to your terms. So if you have, some database class, some model that's defined in a library, and you always use it a certain way, it might make sense to deconstruct that to pull out just the useful bits. Can you overload deconstruct? You can. I mean, it's kind of not really overloading. Well, I guess it is overloading because it's multiple methods, the same thing. But yeah, essentially it's picked based on how this is defined. So if I change this to a long, this is now going to say I can't find a deconstruct method, presumably. Oh. Well, maybe because I've already got one of the method changes, but oh, okay, you can't. That's interesting. I thought you could have multiple deconstructs. Maybe it's by number of parameters. Yeah, no suitable deconstruct with 3 out parameters. Okay, so it's by number of parameters only. That's interesting. But you can't do it by data types. I don't even know what I'm typing anymore. Yay for shitty examples. And that's, of course, taken. Yeah, so that works. So you kind of can have multiple deconstructors, but yeah, only by number of parameters. I guess that makes sense because the return type of any expression is never, it's not used in C#. I wonder if that's going to change though. There's a lot of stuff in C# 9 that they're thinking about or planning with target typing, it's called. So basically basing things off their well, it's not really their return type, but it's where they're going, what's being done with them. So this could be an example where that could change in future. But anyway, there's tuples. Thank you for the fun diversion. Let's go back to what we were doing. So we're just cleaning up this. So yeah, tuples, deconstruction, all very similar. No, sorry for the tangent. The tangents are fun. Tangents is what keeps it interesting, I think. Okay, so back to removing math with prejudice. Is that the word? I don't know. That one's supposed to say. All right, cool. We have hopefully a still working game. Let's build it. Ooh, it's on here. Yay! Oh yeah. Okay. The simplest of algorithms. Can't draw up yet. Do we see? It's so tempting to just go over to the right class, which is this one. It's so tempting to just work on this method now, but is it time for tests? Kind of probably should do some tests before we do anything. Thank you, Don Elliott, for following. Welcome to the club. Yeah, I don't want to do tests. I'm gonna let's just do this. Let's do one thing just before we do tests, because oops, this is making the game fun to play. So it's good to make it fun to play first. It will inspire me. Us. Me. Ooh. Alright, so this should now at least do vertical tracks in both directions. Whoop. And hold the mouse steady. Yay! So yeah, adding in more cases to this little algorithm is probably the next bulk of the work, but after that, It's kind of like, trains is next, I guess. Oh no, we still need to do corner tracks. Yeah, still need to do corner tracks. And yeah, I'm not loving where that method is, the set best track direction. I don't know where it should be, but I could just see it growing in size, Let's commit that for now. Vertical. And yeah, curve tracks. I also think I'm probably going to cheat at curve tracks because I'm so bad at math. Actually, there's one more thing we can do before we do curve tracks or tests. There's one more thing with the drawing that I want to do. I want these end tracks to look different because it looks a lot more realistic when that happens. There's something about it that I think it kind of just takes it to the next level as far as looking like a real game. So yeah, let's do that. So here's where we get. Oh, maybe this is too hard. So here we run into a philosophical problem immediately. How do we know whether a track is at the end? There's essentially two ways. We can find out somewhere here in our render method. So in our track renderer, perhaps, I guess in here, when we're rendering, we say, well, go and find out if there's a track to the left, and if there isn't, tweak the drawing a little bit. And that would work. It means another dependency, so the track renderer needs to be able to call into the game board to find out the track status, but that's okay. So we'd essentially be going, if I've seen the problem. Yeah, so herein lies the problem, right? So let me just firstly explain how I like to solve these sort of problems. Is I like to think about it. How would I like the code to look that I'm going to be using these methods, right? Rather than design the API and say, well, this method belongs here, I like to think of it very much from a usage standpoint. And actually, maybe I should have written tests because this, I think, is a very, it's like a good, I don't know if it's a side effect, but it's good. It's a benefit of TDD. Is that by writing your tests, you're writing your consuming code first. And I think that's a really great way to design APIs. So I could do something like use track at, and then now I need the track, and now I need to know where the track is, right? So I need the track x -1, track .y. Obviously none of this compiles, I'm just exploring, right? So immediately that answers the question as does the track know where it is? Track has to know where it is. Otherwise we end up having to pass the x and y's all the way through. The thing I don't like about this though is that this rendering side of things, so the engine only deals with coordinates. I kind of like the idea the rendering might only deal with pixels. I don't know how realistic that is because, well, I guess it can't because it has to get rows and columns here. So yeah, I mean, this does know. I could just pass in the row and column here. That's easy enough. I could do the calculations here and pass in a flag here. If the track, I mean, a nicer way to say this might be if gameboard dot has track left of. So then even all these -1s and -2s and whatever, +1s, could be removed. And then I guess the other option is, track dot has track at left or something. And I feel like that's the nicest API for sure. But it definitely needs all of the state to be on track, which, I mean, state is not a huge problem, but the more state you have, I feel like we're sort of going away from immutability. And that's, yeah, I don't think that's a good thing. well, maybe it doesn't matter. Maybe it doesn't matter for the actual track. See, the real thing we want to be immutable, well, the reason that immutability has a benefit is when we're drawing, and particularly when we're drawing the trains, or when even when the trains are processing. But we essentially want to be able to say, if we've got this complex method that, let's say the simulate method actually, that simulates the trains moving, if we can give it a game board and know that nothing in that game board will change out from under it, then it means that the code is easy to write. It doesn't have to do lots of defensive work. So immutability gives us a big benefit there. But it comes with the downside. It comes with the downside of making this stuff difficult, because so every time in Gameboard, this set best track direction, this actually has to create a new track with a different direction, and then it has to replace that track in this dictionary. So this dictionary should definitely be immutable, no questions asked. Right? A big part of being able to give an immutable state is to make this immutable. I guess we could have a copy process, but that seems wasteful. Maybe the actual tracks don't need to be immutable though, because if we assume they can't move, no, that's still not good enough, because a train could be coming along on a track, query if the track to the right of it is matching alignment, go to move, and this track would then change. So we do need everything to be immutable. And yeah, so the more state we have on track, the harder that is. What's really frustrating is if we go back to our pretend API here, this if track dot has track left of. What I think would be awesome is if this could be done with an extension method. So the track doesn't need to have all this smarts, but the API still looks nice. The problem with that is the extension method can't, all it would have in this scenario is the track. So it could maybe get its X and Y if we store that on track, but it can't get the game board, for example. It can't get an instance of the game board because it would have to be a static class. Game board's not. So yeah, API problems. I guess if the track had a reference to the board it was on, then the extension method idea works. But when you start adding parameters or fields to things so that extension methods work, you kind of may as well just not have extension methods, right? Maybe this is too much for now. Maybe let's add some tests. Let's add a test project. Oh, is there an X unit? I like X unit. Yeah, it's X unit. Ooh, not sharp. Nothing wrong with F sharp. I just don't know how to code it. I should probably learn. There we are. X unit. Cool. I'm just gonna have one test project. I'm not gonna have separate ones for each thingy. I've just noticed my chat window is not scrolled, or rather the chat window that is on the stream is not scrolled. I'll just solve that another day. Alright, cool. Let's just delete. I can't use mouse today. Let's just delete this. Yeah, so I'm just gonna have one test project, and so it can just render the world. Doesn't need that. Cool. And we're gonna add a class to this called. Alright, let's call it. We'll do the game boards for now. And I don't know, internal, sure. And let's create a fact. So a fact, if you haven't used XUnit, a fact is the same as a test, right? And I want to go set track direction. Actually, you know what? Let's just do this. One thing I hate is naming tests. Set best track direction. Naming tests annoys me because there's lots of debates about it. You know, should be the panel needs to be refreshed. No, the panel doesn't. It doesn't need to be refreshed. It is. It needs to be resized, but it's like there's a portion of the panel being shown on the stream. I think it just reloaded itself. Yeah, so now I've lost everything. Yeah, I don't really know what I'm doing with Twitch, but if you type now, it should be seen. Yeah, it's like an 800 pixel panel being shown in a 400 pixel spot or something. Should just delete it and try to start again. Anyway, yeah, naming tests. Like people have these opinions, like so naming tests should be set track direction, and then I should be like 2 tracks next to each other, horizontal tracks. And I kind of don't like that because it's such a long name. And what happens if a test fails? And obviously everyone is different, everyone has their own coding style, but for me, if a test fails, I go find that test and I run it and I look at what the failure is, or I debug it. I don't actually care if it's called a descriptive name that tells me what it's testing, or if it's called apples and pears, because I'm going to debug it and I'm going to, try and fix it that way. That's just the way that I'm a debugging person. The other thing that I will really want to do is probably make this a theory. So a theory, if you haven't done XUnit before, is where I can say, let's see, we have a track. Let's say we have a track direction. Oops, we have a track direction dot horizontal, track direction dot horizontal. And null. Does null work? Probably not. No. So, okay, we'll do it with strings. What I like to do is theory. So in a theory, what you do is you define your test data. So let's do some test data of no track, horizontal, no track. And then we'll do another row which is no track. Right. So let's pretend we have, this is our train layout, right? We have 2 lines, 2 horizontal tracks in the middle. And we're going to put a track in column 3, row 2. And we expect the track to be track direction dot vertical. So this is, why is this component? Alright. So this would be a so string row 1, string row 2, in column, in row, and track direction expected. So what XUnit does is, so I would have multiple of these inline datas, each with slightly different layouts and slightly different positions where we're going to add a track. And XUnit will call this method over and over again, testing with this scenario. So for something like set best track direction, that's a lot easier than having a test that says if there's one track here and a blank spot and then a track, what happens? But yeah, working at a way of representing that is going to be difficult. So starting with a fact is always, I find, the easiest because, now you're just writing code. So I'm going to create a new game board. I'm guessing that's inaccessible due to its protection. Yep. Game board. Do we do internals visible too? Or do we make this public? Let's do internals visible too. I think there's a way you can do this in a project file. I've not done this before. Internals visible to project file. I think you can specify this. So yeah, there's definitely an attribute. I know that one. Oh, this is interesting. Okay, so maybe it's an extension. Yeah, so this internal visible to. So I'm guessing this generates. Class. Let's just see, just for fun. Let's see if this is in the standard SDK. Interesting. So it's being used. Maybe it's a feature in this build. I really should just try it, see what happens. Yeah, this doesn't really help. Wonder where that's coming from. Let's try it. Let's see what happens. So it was an item. Oops. It was an item group. Internals visible to. Was it include? Probably include, yep. Include Microsoft.net.tests. Nope. That has not helped. Yeah, I really, it'd be nice to do this because, so I can do it with an attribute, which I'll just do for now. Assembly info. The thing is, you don't need an assembly info anymore, so that's why I'm trying to, avoid it, because they get auto-generated. But never mind. Turn visible to trains.net.tests. Okay, we'll get rid of this. Alright, good. Now this compiles. No. Okay. So, what are we testing? We are testing. We need to add some tracks. So we're going to add a track at 1,1. We'll add a track at. No, that'll do. Anyway, board dot. Okay. So this method is not public, it can't be called. I can make it public. I can make it internal. And I can call this. Or I can just call add track and test for the presence of a track in that state. And I think I'm going to do that because that's a little bit more like, it's a little bit of an integration test rather than a unit test, right? I could unit test this method, but what that doesn't do for me is easily allow me to express this tracks. I mean, I could make this take in a tracks collection, or if this was in another service, I guess that's what would happen. Maybe that's the purest way to do it. The problem with that could be tying yourself to an implementation detail. I kind of like the idea that if I call gameboard add track and then I call add track again, I should be able to read off tracks via this get tracks, which is public, and I should be able to check the state. And in fact, if not now, I certainly will need a method at some point, which is like get track at, where I can pass a column and a row. That way what I'm getting is a functional test of the game board, and I don't care how the internals work. I don't care if this is in another service, and I don't care if this is a method on track. I care that when I add 2 tracks to a game board, I get back the right results. I like that style of working because I feel like it's harder to get stuck on an internal implementation detail. This is obviously a very simple very simple program, so it's kind of like a luxury that I get to do this, but I'm going to do it anyway. So now I need to go. Well, now I need my get track out, right? So I'm going to assert equal track direction dot vertical and board dot get track at 1,2. So basically, I've added a track at 1,1. It's going to be horizontal. When I add one below it, it should be then vertical. Let me generate that method because I don't need it actually anyway. And we will just do, this is a track. This is not an iNumeral, it's a track. I shouldn't have generated the method because I'm typing most of it anyway. And we'll return null. And you know what I haven't got in a while? I haven't got a nullability warning. And I just did, so I'm glad that I did because I completely forgot I'd turned that on. Interesting that I hadn't run into that more often. Let's make this public and I'm going to put that on the interface. So I will pull it up to our game board. Cool. Why you not work? To string direction. And I guess I should assert not null. Okay. Let's get the track we want. Let's assert not null. And then we should be able to use now, this is annoying. So what's going on here is a nullability warning because it doesn't know. Well, it's basically saying, hey, track could be null here, and so this little dot could be a null reference exception. We know that it can't be because assert.notNull is going to return what it's going to throw if that is null. Interestingly, decompilation did not work this out. But XUnit asserts, I guess, is not annotated, which is a pity. A real pity. I wonder if there's an issue for it. There probably is. XUnit doesn't release too often, so it could be that it's even been done, but yeah, so there's a feature request. Let's see what Brad has to say about this. Yeah. Huh, there's Drew. What a shock. So Drew's on my team, and Drew annotated all of our code base and all of our system code base. So he's deep in the nullable world. Oh, there we go. He's got a pre-R for it. Excellent. Yeah. So the problem with this is simply waiting for this. So 21 days ago, it's fine. The one time I PR'd into XUnit, it took a few months before the PR was merged, because essentially they don't do releases very often, so which is fine. It's their project. Oops, I just pressed run. I meant to press test. Yeah, we should be able to run that test. Where's the test explorer? There we are. Do we have a test? Get down the bottom, please. The new test explorer, horizontal works, which is good sometimes. Cool. So we have tests. Let's run the test. Should pass. We can test up here. Hey. manual testing. Now, hopefully, what I can also do is turn on live unit testing. But to do that, I really want to write more tests. So I really want this to be a theory. So one of the reasons to start with facts first is you get to you kind of identify the shape of the test as you're writing it. So now that I know how I have written this, I can change this to a theory. And what I can do is I can say, well, my inline data now is going to be a tuple, another tuple, and I'm going to have to do this first. Oh no, we can't have params. Actually, maybe we can. Oh, constants expression. Oh, we can't have constants. Okay, can't have constants. That's cool. We're just going to have to make this. So inline data is where you specify the inline. We can do member data. And member data just means get this from a method called, I don't know, get start data. Needs a better name. Worry about that later. Does it have to be public? Probably. So what get test data, what any member data has to do is return an IEnumerable of an object array. And so IEnumerable because multiple test cases, and object array because multiple parameters. Method group to string. Oh, to string. Okay, that makes sense. And member data should be a static. Oh, cool. And should use name of. Excellent. Well, let's make it static. Good idea on the name of. Does it have a fixer? Yes. And I love these analyzers. The action analyzers are excellent. So what we can do is yield return new object array. So we want 1, 1, 1, 2, and track direction dot vertical. But I don't think I can express that here. Oh, well, I need track direction first. So expected direction, and then I wonder if I can do a params int tracks. Guessing not. Must be a single dimensional array. It is a single. Oh, it's not a single dimensional array. It's a no dimensional array. Okay, that seems to work. I don't know if it'll run though. It might just give us a runtime issue. So all we're going to do is we're going to go for each track in tracks for the track dot _1, track dot _2. I should name these, and then we'll go. Oh, this doesn't return the track. That might be nice. If it was a real API, it would. We're going to assume the last track is the one we want to test. Yeah, that'll do. I think this will change. Tracks dot last link. Oh. Yeah, that's annoying. Whatever, it's only a test. Alright, let's see if this runs. And we want expected function. Does it run? Hey, it runs. Nice. Okay, so now what I can do is I can just add more test cases. So So if we go 2, 1, we expect it to be horizontal. Now the trick is, if we go 2, 1, then 1, 2, we expect that to be horizontal. But this is going to fail, I expect, because this is the case where there's 2 tracks next to each other. They're happy being a set together. We put one underneath, it should detect that and not rotate itself. And yeah, we get to one annoyance with theories, is that depending on what's in the theory, exactly what parameters these are, tracks is not null here. Excellent. That's a weird error. Yeah, so depending on what types these are, it doesn't show them as multiple tests here. So this just says, oh, okay, so this says 2 passed, 1 failed, so that's good. But the test window doesn't. That doesn't matter too much, because what I want to do is I want to turn on live unit testing. And I want to see if live unit testing works. And if it does, do I have to turn on here as well? No. It's building a solution. Okay, cool. So it's busy doing something. And it's running. Okay, cool. So what live unit testing does, if you haven't seen it before, live unit testing, so this is running all of my tests and flagging essentially for every line of code. The minus means this is not covered by any tests. The X means not that this line failed, but that it's covered by at least one failing test. This says it's covered by one test, but it should actually be 2, and I don't know if that means it's covered by one failing or if that's the display issue. No, so that's the display issue, I reckon. Okay, so let's just fix this just for fun. So if the track, yeah, let's, can I invert the if? I want to split the if. So track.direction equals, oh, where'd my live unit test go? Should be running. I thought that wouldn't change the little clocks. So, oh, his live unit test died on me. It has. Snapshot point is great. Okay, so live unit testing is not going to work. So this is a preview build of Visual Studio. It is worth noting. And live unit testing, obviously, some work to do there. That's annoying. See, because what would be nice here is you would see. So if I added a test, let's add a test like this, for example. So if we put one in, one down there and then one above, what it would be nice to see is you would see green ticks for this branch because this part of the test works. But this part of the test would be covered by the failing test. I really like that because then you start adding in more code here, like if the track get track at column, row -1 dot direction equals horizontal. Horizontal, and there is a track at column -1 and row -1. Then and I want to invert this if. I don't want to do that. So basically, so if the track that is above isn't horizontal, or if there's a track to the left of the track that is above. Or if there isn't, then we go vertical. That code could do with some refactoring. So this should make the test pass. It's a real pity live unit testing crashed. Because what you would see, essentially XXX, and then as I write the code, it turns to go green, green, green. Which is just really nice. Unless I'm wrong and this doesn't pass the test. No, it doesn't. So we still fail 1. 1, 1, 2, 1, 1, 2. So 1, 1, 2, 1, 1, 2. Huh. That's interesting. That should have passed. Let's debug it. So when XUnit is happy with your serialization, that's the way. So the way test work is weird, and it has to serialize all your tests, and then when you run them, it runs one of the ones that was serialized, doesn't run them from your code for real. But when it's happy with the serialization, you actually get each individual case listed in the Test Explorer, which makes things a lot easier. So this is not the first one, not the second one, but the third one. So we expect horizontal. We have 3 tracks. Okay, so I'm going to add a track. And we're adding the track to 1, 1. And that's going to just be horizontal. Excellent. Let's put them right there. Now we're going to add a track to 2, 1. So there. Oh, column. Read it wrong. Let's try this again. So it's 1, 1, 2, 1, and then 1, 2. And that should be horizontal. Okay. So I see the problem here. All I did was I went left, and this should be right. So essentially +1. Whoops. +1. I also should get in some helper methods for like is track at, is track left of, etc. So that one, and then so if there's a track above and it's not horizontal, no. Oh right, this not. I need a. Hey, there we go. So that's right. Those tracks are happy, so they stay horizontal. Now on my test should pass. Yeah, this code is going to start to get messy, so helper methods, or possibly some kind of refactoring. Like, we need to do the same things for above and left, and above and right, and below and left, and below and right, etc. So there might be some better things to do there, but just to check my to-do list, we kind of have done auto-determined direction, and we have done tests, so that's not bad. I'm happy with that effort. Whoa. I did not realize that the chat did that. What point did I stuff up my stream? Anyway. Oh, I'm going to start mucking around with the Twitch now, and I'll worry about that later. I'm going to leave it there. Thank you, everyone, for joining me. It was a bit of fun, and and as usual, some more stream stops. Last week was audio. This week was a bit of audio, and they say never play with your OBS setup when you're on stream, and I can see why. Thank you for joining me, everyone, and I'll see you next week or the next time I stream if I get itchy feet and do it before then. Have a good night. Catch up.